Lesson 1.5, solving quadratics by factoring with complex solutions. So we need to think back to solving quadratics and what that means. First of all, quadratic is making this shape, remember, called a parabola or a U shape. It's flipped right side up or it opens up like a smile if the first term, the a squared, is positive. But if it was a negative a squared, then it would be opening down. When we're solving a quadratic, we're trying to find the roots, or really the x-intercept. So in this example right here, that would be here and here. So this one would have two solutions. Sometimes it only has one solution. If the vertex, or that turning point, is actually on the x-axis. And then I want to specifically look at this function, f of x equals x squared plus 144. I want you to graph this on Desmos and find its x-intercepts. Now you can pause and put it on there. You can bring up a new tab. I have to do it on my phone, which I apologize, my phone screen is kind of cracked, because I don't know if there's any other way I can record another screen with my computer. So I'm going to pull it up here. So you see that I put in x squared plus 144. You should know the a term is positive, so it will open up. And I don't see it. And you're thinking, well, what the heck? Where did it go? So then I'm going to start zooming out and out and out, and there it is. So really, my quadratic, it has a y-intercept of that 144 value. Okay? And then I think, yep, see right there. So let me ask you this, where are its x-intercepts? Since the bottom of it's all the way up at 144, is it ever going to cross through the x-axis? Well, no. So sometimes we get these weird quadratics where we used to say no solution. Well, technically there still are solutions, but we get complex solutions out of this. And that's what we're dealing with today to be able to work with I. Okay. Remember that when we are factoring, we always want to check for GCF, or greatest common factor, first. You have to do this or your problem won't come out right. Number one is x squared plus 144 equals 0. That's the one we just graphed. And we said, well, it doesn't have a solution. Yeah, it actually does, because some mathematician created I so that we could have solutions for everything. Yay. In this problem, I don't see a GCF because I can't take anything away from this as a 1, and I can't factor out an x. So what do? I could do quadratic formula, but I'd rather not. I'm going to think, how could I factor this? So I know x squared is x times x. Back up. I was thinking that was going to be difference of squares, but duh, it's not. So hold on. I guess I shouldn't have called that just factoring. So on this one, what I really would have done and will do is, since there's an a term and there's a c term, and what I'm meaning is standard form of quadratics, a squared plus 8x squared plus bx plus c. There's no b term in this. So what I would do is use square roots method, which is where I subtract 144 on each side, which will get me negative 144, and then square root both sides. Square and square root cancel, so I get x. Remember that I do get positive and negative versions of the answers. And then I can't really square root a negative, but I do know that this is really square root of negative 1 times the square root of 144. Square root of 144 is 12. Square root of negative 1 is I. So my solutions are plus or minus 12i. We don't have any other like equivalent value. There's no decimal for that, because really on the graph it looks like it doesn't even exist. So that's your answer. All right, so number 2, we have 1, 2, 3, 4 terms. Quadratic formula would never work for this. We need to check and see if there's a GCF. We got a 2, a 3, a 32, and a 48. No, not going to work. And then this term doesn't have an x. So when there are 4 terms, you're going to factor by grouping. That means out of the first 2 terms, what can I take out? Well, I can only take out an x squared. And that leaves me with 2x plus 3. The sign between the 2 middle terms is what you always bring down. What can I take out of 32 and 48? 16. And then that would leave me with a 2x plus 3. And remember, when you're doing grouping, things that are in parentheses should always match exactly. If they don't, then you did it wrong. But how we actually write our answer is we take the two GCFs and put them together, x squared plus 16, and then these become just one factor. Okay, and now we want to solve them. Remember that this part times this part is trying to make 0. If we can make one of them equal 0, then when we multiply by 0, it makes the whole thing. So we're setting each factor equal to 0 and solving. To solve this, I would subtract the 16 over, making it negative, and then I'm going to square root. And we'll get two answers. Square root of negative 16 would be plus or minus 4i. There's that. And then this one's easy. Subtract 3. And then divide by 2. Which you can probably do that in your head. So I also get here a negative 3 halves. So we get plus or minus 4i. Come on. And negative 3 over 2. Okay. All right, number 3, you should notice that it has 1, 2, 3, 4 terms. The difference in this one is that I do z all the way to the last term has some x's, so I can take something out. And when the first term is negative, ever, take a negative out, and that's going to save you so much headache. Okay, so what I would do is take out the negative, and I can actually take out x squared. You always take out the smallest amount, and then that means all of them have that. Figure out what's left. So this would be an x cubed. This would be a minus 4x squared. And always double check, okay, if I distributed, would that end up with this again? Yes. And then that would be a positive x. And then this would be a negative 4. Okay? But I'm not done. I still have 4 terms inside of here. This negative x squared is still a factor, though. Don't forget about it. I'm going to have to get answers out of that guy when I'm all done. But I'm going to just deal with these 4 terms that are left. Okay, I'm going to factor by grouping again. I can take out an x squared. That would leave me with an x minus 4. Bring down my plus. I don't see anything I can take out. So I'm going to have to take out like a 1. And then that's going to stay x minus 4. They match, so that means I did it right. And then my answer is going to be x squared plus 1 times x minus 4. But don't forget about this guy. Negative x squared is still a factor. I should end up having the same, like if I added all the powers on x, I should end up with the beginning number. So 2, 4, 5. See how it's the next to the 5th? All right, now draw lines down through each factor. Negative x squared equals 0. I could divide by negative 1. I could square root 0. That's just going to be 0. And there's no such thing as plus or minus 0, so it's just 0. This one, subtract 1, square root, that gets plus or minus I. And then this one's easy, this one just gets 4. So my solutions would be, and I don't care about the order, 0, plus or minus I, and 4. Okay. Number 4, you can try this one. So pause and try it by yourself. All right, since the leading term was negative, I took out a negative 3x squared. That left me with an x squared plus 4. This is always going to get a 0. When you have a monomial times x, the only possible thing is 0. And then when I square root negative 4, I get plus or minus 2i. Hopefully that went okay. You can go ahead and try number 5 as well. I would like to mention that anything that has over a squared term needs to be factored again because you can't fourth root this to get all the solutions. So this right here is a difference of squares. When it has two terms, subtraction between the terms, this has an even power and this is a perfect square, you need to factor again. Remember that difference of squares will be two binomials. You square root the first term. So x squared times x squared makes x to the fourth. One's going to be plus, one's going to be minus. Square root of 16 is 4. Now it's factored enough that you can go ahead and get your solutions. So 4 times what would be 0, or 0 divided by 4 is 0. Subtract the 4 over, square root the negative 4. That would be plus or minus 2i. Add the 4 over, and square root 4 is plus or minus just normal 2. I get 0 plus or minus 2i plus or minus 2. All right, and there you go.